radicals, okay, as studied in Math 10C. So a lot of this should just be review of radicals concepts, right? So 3 squared is 9. Since 9 is the square of 3, we say that 3 is the square root of 9, right? So 3 is equal to square root 9. Now, usually we don't write the little 2 in there, okay? But 3 cubed is 27. Since 27 is the what? Of 3. The cube of 3, then we say that 3 is the cube root.
Would it be like the third power?
Yeah, you can say it's 3 to the third power. Well, we tend to say cube, so we can say cube root. 3 to the fourth is 81. Since 81 is the fourth power of 3, we say that 3 is the fourth root of 81, right? So 3 is the square root of 9, the cube root of 27. 3 is the fourth root of 81. 3 to the fifth is 243. Since 243 is the fifth power of 3. We say that 3 is the fifth root of 243. And to indicate fifth root, we put a 5 in here, which is called the index, and write 243 under the radical sign. So expressions such as the fourth root of 81 are called radicals. A radical consists of an index, which tells you which root, unless it's not there. A radical sign, which is that symbol, and the radicand, which is the thing you are taking the root of. Most common index used is 2, and to save time, we often do not write the index of 2. So if no index is written, then it is understood to be 2. So for example, the square root of 144 is the square root of 144, right? Root 25, sometimes just call that root 25, right? Because we use square roots more often than anything else. Is square root 25. Okay, so let's complete the following table. Should be able to do, right? So go ahead, complete the following table. And I should. All right, so there it all is. Any problems, concerns, questions, comments? Where the heck is everybody? The zoo, right, yeah. That's where I went yesterday. So, all right, we're missing a bunch today for that. Well, that's why I handed out all this stuff last week, right? So everybody's got the booklet and stuff. Anyway, okay, have a decent day. Weather was nice yesterday. Okay. So let's do with square roots. If x is the square of r, then r is the square root of x. That is, if r squared is equal to x, right? So x is the square of r, then r is equal to the square root of x. Some numbers have a square root. I knew that. I saw something flash up there. Only in 20-1. Some numbers have a square root, but there are many actually, numbers for which you cannot take the square root. What numbers do not have a square root?
Negative numbers.
Yeah, negative numbers, right? We can't take the square root of a negative. Well, they might have a square root though, right? You're going to have to rewrite the negative. You can have a rational number, like 4 over 9 has a square root, which is 2 over 3. You could take the square root of only a positive number or 0. Yeah, here we go. That is, root x exists only if x is greater than 0. Sorry, greater than or equal to. Okay, so negative numbers do not have a square root. If x squared is 9, there are 2 possible values of x. What are they? 3 or negative 3. So you can't take the square root of a negative, but if you square a negative, you get a positive. So every every square root has Okay, how many square roots does a positive number have? There are two, right? There's a positive and a negative square root. But the symbol, root x, always denotes the positive square root, right? So if you see the radical sign, okay, so if I say x squared is equal to 9, then you say x is plus or minus 3. If I say the square root of 9, you say 3. Okay, so this symbol, the positive or principal square root. And this, well, what value do I square to get 9? Then there are 2, right? So although numbers have a positive and a negative square root, the radical symbol always denotes the positive. List the first 15 perfect square numbers. Okay, so go as far as you can. You should be able to list these guys. And even if you don't kind of have them memorized or that, you should, well, the first 15, you should memorize these, right? Like you should know that, 49 is a perfect square, right? So we got 1, 4, 9. You should know that 121 is a perfect square. And 196 is a perfect square, right? So you should know that because then you'll know, oh, well, there's a square root, right? So if you see 288, you can say, oh, that's 2 times 144, and 144 has a square root, right? So that I could change it to a mixed radical. That's what we're getting into a bit later. List the first 10 perfect square powers. Does it say 10 on yours or 5?
It
says 10. What's the first 10 perfect square? I think it should be 5. Right? There's only 5 here. 1, 2, 3, 4, 5. Yeah. So perfect square power. So that is x squared is x squared. What's x squared squared? X to the 4th. What's x cubed squared? What's x 4th squared? And what's x 5th squared? Okay. So now we know then that x squared has a square root, right? Because we just squared x to get x squared. We know that x to the 4th has a square root. X to the 6th has a square root, right? Which is what? What's the square root of x to the 6th? What's the square root of x to the 6th? X cubed, right? What do you do? What's that sheet of paper, white thing over there saying? You have the power. Okay.
But why? Like, wouldn't it make sense if you're like square rooting?
If I'm square rooting x to the 6th, what do I get?
But wouldn't you just be taking out like the two?
No. I'm looking for something which, when multiplied by itself, gives me x to the 6th. What do the exponent laws say? Right? If I square x cubed, what am I doing with the exponent? I'm multiplying by 2, right? The x to the 3 times 2, right? What's power to a power? You multiply. Okay, so 3 times 2. So how do you find the root? Okay, say over there. You have the power. Only have is held, right? H-A-L-V-E. But it's a pretty good pun. A power is a perfect square if its exponent is, what, 2, 4, 6, 8, 10? Even. To find the square root of the exponent, to find the square root, you divide the exponent by 2, right? It's even, it has a square root. To get the square root, we divide by 2, right? Divide the exponent by 2. Cube roots. If x is the cube of r, then r is the cube root of x. That is, if r cubed equals x, then r equals the cube root of x. State the value of each cube root. What's the cube root of 27? 3. What's the cube root of negative 64?
4.
No. 4 times 4 times 4 is 64. It's negative 4. Okay, it's not positive. This is not square roots, right? With square roots, well, first of all, you can't do the square root of a negative, right? As a matter of fact, to extend that you can't do the even root of any negative number, right? But odd numbers, they can be negative, right? You can do the root of an odd number, or of a negative number. You can do an odd root of a negative number, right? Since, negative 4 quantity cubed, write it like that, is equal to negative, negative 4 times negative 4 times negative 4. So what happens, right? These two negatives pair up, become positive, but it's odd, so there's always one extra negative, right? So if this was 9th power, then I'd have 4 sets of, negatives that would pair up and become positive, but there's always one left over. So that's negative 64. So you take the cube root of any number, right? Positive or negative. Cube root of a positive number is positive, and the cube root of a negative number is negative.
So if it was the square root of negative 64, there would be no answer.
Right. Can't do that. Bring out the NHL ref. Couldn't do that. List the first 10 perfect cubes. Okay, so again, you should know perfect cubes, right? And the idea is just that if you see 343, even if you don't know it's 7 cubed, just know that it has a cube root, right? So you see 343, it has a cube root. Okay, now what is it, right? And it might take a minute to find, not a minute, but like 6 or 7 or 8 or something. So 1 cubed is 1, 2 cubed, 3, 4, 5, 6, 7, 8, 9, and 10. Right? So be able to recognize those numbers. Oh, I see 729. I know that that's a perfect cube. Okay? I may not know what its cube root is, but I know if I go to my calculator and type in cube root of 729, I'm not wasting my time, right? If I go to my calculator and type in what's the cube root of 672, I'm wasting my time, right? Unless I'm trying to find an extra decimal, right? But it's not a perfect cube. So we need to know perfect squares. We need to know perfect cubes. This is the first 5 perfect cube powers. So x cubed is x cubed. X squared cubed is x to the 6th. X cubed cubed is x4 cubed is. And lastly, so a power is a perfect cube if its exponent is, not all odd. 6 is not odd. So what's it got to be? 3, 6, 9, 12, 15. Multiple of 3. So is a multiple of 3. To find the cube root of a power, what do? Divide the exponent by 3. Right? There's no nice word for dividing by 3 like there is for dividing by 2. Divide the exponent by 3. So we don't take half. We say, well, look, it's divisible by 3, right? Because when I cube something, right, remember what do, right? We cube something, we multiply it by itself 3 times, right? So x cubed is, we power to a power, we multiply the exponents, right? It gives x to the 9. So if your exponent is divisible by 3, you can cube root it, right? So you cube root numbers. What's cube root of 512? 8. What's cube root of x 15? X to the 5th, right? Divide that by 3, get its cube root. Higher roots. The number 16 is the 4th power of both 2 and negative 2, since 2 to the 4th is 16, and negative 2 quantity to the 4th, right? Like I can't just say negative 2 to the 4th. That will just disappear anyways, right? If I say negative 2 to the 4th, what does that mean? Right? Is it what I wrote there, the negative of 2 to the 4th? Because that's going to be negative, right? Because I got to do 2 to the 4th first, and then bring the negative sign in. That's order of operations. So you do the exponent first, and then, okay, you got the negative in front. Okay, so, that's why I will say negative 2 quantity to the 4th, right? Which means the negative 2 quantity means write negative 2. Oh, now stick brackets around it. So negative 2 quantity to the 4th becomes positive 16, right? Because if you raise a negative to an even power, you get a positive value. All right, that's just clear. We can keep going. So the radical, the fourth root of 16, represents the positive fourth root. Okay, so any even root is just a positive number, and you can only take an even root of a positive number, right? Can't do an even root, second root, fourth root, sixth root, eighth root, 10th root. Okay, speaking of fire drill roots, out there, down the stairs, out to the park, by the tree, by the bench there. Higher roots. The number 16 is fourth, like we got that far, right? The radical fourth root of 16 represents the positive fourth root, okay? So any even index. We don't really get much into sixth roots or fifth roots or anything, but I mean, they exist, obviously. The positive fourth root of 16, that is, fourth root of 16 is 2. Like square roots, we can only take the fourth root of a positive number or 0. List the first 5 perfect fourth powers. So 1 to the fourth is 1, 2 to the fourth is 16. They gave that one away. What's 3 to the fourth? 81. What's 4 to the fourth? 256. What's 5 to the fourth?
625.
Good. Okay. And then, you know, like 6 to the fourth is like, I don't know, it's big, right? It's like 1296. And 7 to the fourth is, I don't know, 21, 22. Yeah, that gets really big, right? And then, you know, so if you know you're looking for a fourth power or something. Now, what about variables? What's x to the fourth? What's x squared to the fourth? Okay, so if you see x to the 8th, you say that has a fourth root because this is divisible by 4. What's x cubed to the fourth? And then, okay, so if the exponent is divisible by 4, you can take a fourth root. Divisible by 3, cube root. Divisible by 2, square root. Since 2 to the 5th is 32, the 5th root of 32 is 2, and we write the 5th root of 32 is 2. Similarly, since negative 2 quantity to the 5th is negative 32, we have the 5th root of negative 32 is negative 2, right? So odd roots have, you can take the odd root of a negative number, right? You can't do that. You can't do even roots of negative numbers. So, like cube roots, you take the 5th root of any number, or the 7th root, or the 9th root, or the 11th root, and so on. The 5th root of a positive number is positive, the 5th root of a negative number is negative. List the first 5 perfect fifth powers. 2 to the 5th, 32. 3 to the 5th, 243. 4 to the 5th, 1024. And 5 to the 5th, 3125. Okay? Those, I don't expect you to memorize those or anything, right? I mean, if you got to take a 5th root, we'll show you on the calculator, maybe, if you're good. X to the 5th. X squared to the 5th. So what's the common thing here? They're all going to be divisible by 5. Okay? So numbers have 5th roots, variables have 5th roots. Summary. Not really, it's kind of cool. It's more springy. A radical, there, it flashed again. See, nothing good is going to come of this. Look, thin line, right? Why? Why only, and only this stuff? A radical is an expression of the form the nth root of x, where n is a natural number. Where do the natural numbers start? Just killing time until we get 1, right? So natural numbers are the counting numbers. Oh, it reminds me, 3-2, we're doing counting today. 1, 2, 3. The symbol is called the radical sign, and n is called the index. I might have switched over. I think that line doesn't look so thin. And x is called the radicand, right? The thing that we are taking, and the index tells us which root we are taking, and the radical sign says you are doing a root. Index, what root? And the radicand, what root of what? If the index n is blank, then the radicand exists for all values of the radicand. odd. Because if the index n is even, see if you just read the next one, you'll know what goes in that one. It's not positive, because then that would be negative. No. If the index n is even, then the radicand must be positive. If n is even, then the expression represents only the positive root. Okay, remember, if it's odd, you don't have a positive root and a negative root. You have a positive root or a negative root, right? Like it has a root. There's more, though, isn't there? Simplifying radical. Nothing flashed. Simplifying radicals. A radical is in simplest. Do you remember simplifying radicals? If not, well, we're going to go through it again. A radical is in simplest form if the following are true. The radicand, right, which is the thing under the radical sign, does not contain a fraction or any factor which may be removed. The denominator does not contain a radical, right? So radical is not in simplest form. Root 24, the square root of x to the 7th, right? So it's got a factor which could be removed, right? In this case, a perfect square. In this case, you got a perfect square. In this case, the denominator contains a radical. In this case, the denominator contains a radical. And in this case, the denominator contains a radical. Okay, express as a simplified mixed radical. State the values of the variable for which the radical is defined. Okay, so in this case, the whole thing. It'd be more the restrictions, right? What's the restriction? You say, well, x could be any real number, right? There's no restriction, or x has to be greater than or equal to 0. So when we're saying the values, we're really just saying state the restrictions. Okay, root 72. What do we do with root 72? 6 root 2. I mean, really what I'd like you to do is just look at that and say 6 root 2, and then just write 6 root 2. But here's how it goes, right? So when we're simplifying this is an entire radical, right? The entire thing is a radical. We want to change it to a mixed radical. We say, what is the largest perfect? Now in this case, these are all square roots, right? So we're just saying, what's the largest perfect square that goes into 72? 36. So I'm going to rewrite root 72 as the root of 36 times 2. So all I'm doing is I'm factoring 72 underneath the radical sign, right, as writing it as a product of two numbers, one of which is a perfect square. And then we split this. So we say the radical of a product, okay, the square root of a product is the product of the individual square roots. So this is root 36 root 2, and root 36 is 6, so it becomes 6 root 2. Okay? You can do that in one step, right? You just look at that and just say 6 root 2 and write 6 root 2, and it's all good. Okay? And if you want, you can show it that way, right? Okay, so 150, you can look at 150 and say, oh, that's just 5 root 6. Okay, some of you are going, wait, 5 root 6, how? Okay, so again, we're just going to do the same idea, right? So what's the largest perfect square that goes into one? Now remember your perfect squares, right? You got 1, 4, 9, 16, and 25, 36, 49, etc., right? So largest perfect square that goes into 150 is 25, and 25 goes into 150 how many times? 6. So we write root 25 times 6. Then we write that as the product of the radicals. And we take the square root and get 5 root 6. Okay? 5 times the root of 96. Okay, root 96. What's the largest perfect square that goes into 96? Okay, so 4 goes in. But if 4 goes in, here's what you got to look for. With square roots, if 4 goes in, maybe 16 goes in, right? Because 4 goes into 16 as well. Maybe 64 goes in. It doesn't, but maybe it does. So if you divide it by 4, and then you get 24, then just look at 24 and go, wait, oh, 24 also is divisible by 4. Or if 96 is divisible by 4, is it divisible by 16? And the answer is yes. So this is equal to 5 root of 16 times 6, which is 5 times root 16 root 6, which is 5 times 4 root 6, which is 20 root 6. Okay. How do you know they're the same? You can just plug them into your calculator if you wanted, right? Just go 5 times root 96, enter, and go 20 root 6, enter, and they should be the same, right? They're the same. You got it. Now, doesn't mean it's in lowest terms, right? So the last thing you want to check is the number that's under the radical sign when I finally end up there. Is there any perfect square that goes into it, right? Does 4 go into it? Does 9 goes? Because we don't always take. Maybe with 72 we go, it's 9 times 8. And then we go, it's 3 root 8. Right? And then you got to look and say, oh, wait, but 8's divisible by 4. Okay? So that's, you got to keep going. What's the square root of x to the 10th? X to the 5th. This just has a square root, right? How do you know? Because you can divide the power by 2. So this is just equal to x to the 5th. Y to the 25th? I can't divide 25 by 2. What number less than 25 can I divide by 2? 24, right? So we're looking for the largest even number, right? It's a square root, so it's going to be even. Cube root, it's multiple of 3. Fourth root, it's multiple of 4. Yep.
Can't it just be y to the power of 25 over 2?
Nope.
Isn't that the same thing, though?
Yep. But it's not a simplified radical form. Right. So, we're going to rewrite this as the largest even number, less than 25. If this were a cube root, it would be the largest multiple of 3, less than 25, which is still 24. If this were a fourth root, it would be the largest multiple of 4, which is less than 25, which is still 24. If this were a fifth root, it would just be y to the 5th, right? Because you can divide 25 by 5. So to square root, we want an even power, biggest even power, right? And then you get this. Okay, and then you split it. And what's the square root of y to the 24th? Y to the 12th, root y. So that's our answer, right? It's y to the 12th, root y. So we pull the largest even power, right? Because we got to write it in radical form, right? Radical form, you use radical sign. I mean, you're right. It is y to the 25 over 2, right? Which is the square root of y to the 25th, which is what we're starting with, though. Right. See, all writing is y to the 25th to the power of 25 over 2 does get us right back to that radical, okay? But it doesn't give us a simplified radical. A to the 11th, b to the 6th. Okay, can you divide 11 by 2? What can you divide by 2? Okay, so we're going to go a to the 10th. Why? Because it has a square root. What about b to the 6th? Okay, so I'm going to go b to the 6th next. So what I'm going to do is I'm going to write everything that has a square root. A to the 10th has a square root. B to the 6th has a square root. What's left? A. Okay, so I'm going to do that. Now what I'm going to do is I'm going to write the square root of the things which have a square root, right? So it's the square root of a to the 10th, b to the 6th, times root a. Okay, now I'm going to say, what is the square root of a to the 10th, b to the 6th? A5b cubed, right? Root a. You want to go from there directly to there, that's fine. Okay? So I don't need to see work. We should basically be saying on here like state. Okay. But keep in mind, if we say determine, it means we want to see work. Look at marks as well. If something's worth 3 marks, it's probably not a one-line solution. Right? It's like, oh, I'm just going to write the answer. 3 marks is, they're giving me marks for something. Okay, sorry, do you have a question? Okay, 20, b to the 9th. So here, now I'm putting it all together, right? So, first thing I want to write this as a product. I want numbers, so I need a number. What's the largest number? What's the largest perfect square that goes into 20? 4. What's the largest perfect square that goes into b to the 9th? B to the 8th. What's the largest perfect square that goes into c to the 5th? C to the 4th. Okay? So here's what I've done. I've written down all of the factors of 20, b to the 9th, c to the 5th, which have a square root, or which are perfect squares. Okay, that makes sense? Now, what's left? I still need a number, 5, and I need a b, and I need a c. Okay, so, has a square root, doesn't have a square root. Okay, so we split it. Has a square root, doesn't have a square root. And what's the final line?
2 before C2.
Yeah, 2 before C, 2, I before E, except after C, except the C is before, no, the B4 is before, no. Okay, yeah.
Don't stop listening, I'm just messing.
Okay, so square root of 4, right? So what do? We take the expression, right? This is what you're going to do. This is it, right? Like this applies to everything from this point forward for all this stuff here. Right? It's cube root, you just want perfect cubes. So what we're doing is we are factoring the expression under the radical sign into perfect whatevers. Squares, cubes, fourths, fifths, 11. No, it won't be 11. We're not going to go that high, right? Okay, and then you're writing it as a product of the things which have a root, whatever root it is we're looking for, and the things which don't. And then we split the roots up, and then we take the root of that, right? So cube root 40 is, we'll do the details, right? We're just going to do all these, we're just going to do full details. So what do I write 40 as? 8 times 5, right? So, cubes, right? What are the cubes? So, you might be flipping in your book, booklet there a little bit, right? You might be flipping in your booklet saying, okay, wait, cubes, right? So I've got 1, 8, 64, or 27, 64, okay? So 40, well, 8 times 5 is cube root 8. Cube root 5 is 2. Cube root 5. Okay, how do I know they're the same? I could take the cube root of 40 on my calculator. I can go 2 times the cube root of 5 on my calculator. I can say, hey, they're the same. All right, cube root of negative 500. All right, so here's a little thing now. We're going to agree to do it this way. Well, okay, this is how it's going to be marked. You probably want to do it this way. Okay. If there's a negative, this is going to be our standard, right? Because we've got to decide, what do we do with the negative, right? If it is a odd root and it has a negative under the radical sign, then we are going to take the negative as part of the perfect cube and then pull it out, and so we're going to have a negative. We're going to have with a negative in front, not underneath. Okay? That's the agreement. If it's the cube root of a negative, the negative is going to end up out front. Okay? And then we'll have the cube root of a positive. All right, what's the largest perfect cube that goes into 500? 125, right? How many times does it go in? 4. Okay, so cube root, negative 125 times 4. Okay, so anytime I have an odd root, I'm putting the negative with the perfect root. Okay, which is equal to, and there should be an equals, all right? Which is equal to the cube root of negative 125 times the cube root of 4, which is equal to what? Yes, right, that. That's what it's equal to. Negative 5 cube root 4. Right, so the idea, if we have a negative under the radical sign and it's an even root, we're just going to say you can't do that. If we have a negative under the radical sign and it's an odd root and we are changing it to mixed, we're going to pull the negative out in front of the radical. All right, what if there's a negative 8 cube root 576? So what's the largest perfect cube that goes into 576? Sorry, what? 64. Okay, how many times does it go in? 9 times? Okay, equals, so we're going to keep the negative 8. It's just along for the ride. Got the cube root of 64 times 9, which is negative 8 times the cube root of 64 times the cube root of 9, So watch out, when you're doing anything higher than a square root, make sure you're writing the index in each time, right? Very important. Is negative 8 times 4 times the cube root of 9, which is negative 32 cube root 9. Okay, ready? Here's a big one. The cube root of m to the 17th. What's the largest perfect cube for m to the 17th? M to the 15th, right? So what are we looking for? The highest multiple of 3 less than 17. And that's 15, right? So it's the cube root of m to the 15th, right? That has a cube root. How do I know? Because it's divisible by 3, right? You third the power. I guess actually is a word for how when you're talking about 3 thirds. That's confusing, right? Because it's the third power, or the third. You take a third of the power. Okay, and then what's left? We got m to the 15th and m squared. Which is the cube root of m to the 15th. So this thing has a cube root, and the cube root of m squared, which is, what's cube root of m to the 15th? M to the 5th, cube root m squared, and what's the restriction? It's an odd power, so there's no restriction, right? It's an odd root. No restriction, it could be anything, right? M could be positive, and it could be negative, doesn't matter. Okay, it's a square root, 4th root, 6th root, 8th root, 10th root, 12th root, etc. Even root can't be negative.
Do we have to specify that?
Yes. In general, no. You just need to be aware,
Yeah.
right? Again, there's a lot of these things where when you're solving stuff, it's like, oh, do they have state restrictions? No, but they need to reject the answer that isn't an answer. Why isn't it an answer? Well, it's one of two things, right? Either it doesn't, contextually, it doesn't fit the question. You can't do negative 5 hours of work, and the length can't be negative 3 centimeters, right? Or, you know, we know that value has to be positive, so. Okay. Do this. If you can do this, then you're in pretty good shape for today, anyways. Okay, let's give this one a try. Because it combines everything, right? It's got variables, it's got numbers. You're looking at perfect cubes, so you might have to flip back, look at the perfect cube, say which one of these goes into 108. Let's get the calculator out, be tapping away on the keys. Okay, remember, we're going to keep the negative with the perfect cube, right? Keep the negative with the perfect cube. Then it's going to come out, right? Because it's going to have a cube root. Messed that up, didn't I? Hope you're not just copying what I wrote. Okay, what's wrong with that?
You can take one of the R's out if one's a perfect.
Yeah, but we're looking for perfect cubes.
Yeah, one's a perfect cube.
The R? There's only 2 R's. It's R squared. I can't take R out.
64 times 2.
64 times 2 is 128.
Because cube root of 64 would be 4.
64 times 2 is 128.
Oh,
27 times 4 is 108. You can use a calculator.
Oh, you didn't put a.
I didn't put a 3 in the index, right? Sorry, there was less wrong than you thought. No, it's not 64, right? I had to think for a while before I realized 27. Usually they're fair. When we get into cubes and 4th roots, we don't usually give you like the bigger ones, right? It's not like all of a sudden it's divisible by 1296 or something. But maybe it is. Okay, you just gotta keep that in mind. You gotta play with it a bit. I mean, the big thing really is, at the end, look down here. So what's the largest power I should see under a cube root sign? What's the largest power that I could possibly see? Squared. What's the largest power I could see under a fifth root sign? 4. What's the largest power I could see under a 15th root sign? 14, right? So if I have anything that's 3 or higher under a cube root, then I should have taken that out, right? It belongs in the other part. So the largest power that you can have is 1 less than the index, right? So if I'm doing fifth powers, I can have a 4th. But that's it, right? Because we're taking out, so like p to the 7th, right? We're taking out what's the largest multiple of 3? P to the 6th. What does that leave? A number less than 3. Okay, that's good, right? And it's p to the 6th, and p to the 1 gives me p to the 7th. Yeah, it just keeps going on. When will it end? Well, when will it end?
It's just like,
That's never going to end, sorry. 10:17, then I'll go. All right, 4 through to 64. What's the largest fourth power that goes into 64? 16, yeah. Oh, great. Okay, so it's the 4th root of 16 times the 4th root of 4, which is 2 4th root of 4. So it's the 4th root of 16 times the 4th root of 4, the 4th root of 16 times 4. Okay, 162. Got to be 81, right? 81, so this is the 4th root of 81 times 2, which is the 4th root of 81 times the 4th root of 2, which is 3 times 4th root of 2. Okay, now if you look at 162 and go straight to 3 times the 4th root of 2, I'm pretty sure we're not going to say determine. You know why I say determine when there's variables? Because then you have to show intermediate work, right? Like, or you really should. Okay? Don't do too much at once. You guys like to do too much at once, and then things don't usually go well. Okay? So split it out. Oh, look, it says the sun has reached 30 degrees above the horizon. I thought it was 35. Okay, -2, 4th root. If there's any negatives, they have to be outside, right? You can't. We have negative there. You just go, I can't do that. All right, what goes into 1875? Like 625, right? Times 3? Yeah, that'll work. Okay, so it's 4th root of 625 times 3, which is -2 times the 4th root of 625 times the 4th root of 3, which is -10 4th root of 3. Okay, I'm going to skip a small step there. Oh, did we miss something? Oh, variable-wise, right? What? Hang on. We never stated the values of the variables. Oh, yeah, you're right. It's like, why did you go back? Yeah. Oh, it's horrible now. You know, we'll never get, I can't even. Oh, why did you do that? Well, we were supposed to state the values of variables, and I didn't state the values of the variables for some of them, so we need to fix that. Okay. It's not going to matter, right? Because if it's negative, it's getting raised to the 10th power, it'll be positive. Here, y has to be greater than or equal to 0, because you still have a root y. And here, a has to be greater than or equal to 0, because you still have a root a. And here, b and c, well, both. So b has to be greater than or equal to 0, c has to be greater than or equal to 0. Okay, and then we got the m, and then here, p, oh, no, here, doesn't matter, right? Because it's a cube root, then there's no restriction. So p belongs to the reals, r belongs to the reals. All right, then we go to the 4th root. As soon as it's going to die yet. So what's 512? It's like, oh yeah, of course. 256, right? 4 to the 4th? Decide whether or not you were correct in your assumption that if I can do these, then I can do that. Okay, what did we have? What was it? 256? M to the 20th, and then 2m cubed, right? That's correct. So the fourth root of 256, m to the 20th times the fourth root of 2m cubed, which is okay, right? Because the largest power that I can have under a fourth root is 3. So 4m to the fifth. So I just take the fourth root of 256. I divide 20 by 4. Okay, and then I have the fourth root of 2m cubed. Okay, this one, fourth root, right? So it becomes what's left. Okay, a to the ninth. So what's the largest multiple of 4? It's 8. So a to the 8th. C to the 7th. B is squared, right? That's under 4, so it's just going to... C to the 7th becomes C to the 4th. Okay, and what are we left with? We got an a, and we got a b squared, and we got a c cubed. Okay, anything we're left with must have an exponent which is less than 4. Okay, which they do. It's good. Okay, so we got the fourth root of a to the 8th, c to the 4th times the fourth root of ab squared c cubed, which is a squared c times the fourth root of ab squared c cubed, and a, b, and c are all greater than or equal to 0. Actually, wait, not true, right? Because the b is being squared, so the b does not have to be greater than or equal to 0. So a has to be greater than or equal to 0, and c has to be greater than or equal to 0. Well, again, even that's not true. A is greater than or equal to 0, and c is greater than or equal to 0, or a is less than or equal to 0, and c is less than or equal to 0. Because if they're both negative, then we'll have a negative, and when we cube the c, it'll be negative. The b will always be positive, it's b squared, right? So when I take a to the first power and c cubed, if they're both negative, then I'll have a negative times a negative, which will be positive, so that'll be okay. So either a and c are both positive, right? So what we need is this. We need this expression to be positive. And that will happen if both a and c are positive, or if both a and c are negative. So a little trickier on that one. The fifth root of 486. So what's that? It's going to be like what? 243? So it's fifth root of 243 times 2, which is the fifth root of 243 times the fifth root of 2, which is 3, fifth root 2. Negative 128, right? There's no restrictions or anything here, right? It's fifth root, it's odd, therefore it could be positive or negative. So fifth root, negative 32 times 4. Okay, if there's a negative under the radical sign, and then it has to be a third, fifth, seventh, whatever root, we're going to pull that negative out front by putting the negative with the perfect fifth. Fifth root 4, which is negative 2 times the fifth root of 4. 6250. I'm just looking at my little cheat sheet here, right? It's 3,125. 3125 times 2. Don't forget the little equal signs in front. So 3125. Fifth root of 2, which is 6 times 5. That's fifth root, which is 30. Times the fifth root of 2. Watch your index, right? You could lose half marks for index, missing indices. X to the 14th. So what do I need? X to the 10th, right? So largest multiple of 5 less than 14. So it's x to the 10th times x to the 4th, which is the fifth root of x to the 10th, fifth root of x to the 4th, which is x squared, fifth root x to the 4th. 96. What's that? What 32 and 3, right? Yeah, okay. Fifth root. So 32, c to the 5th, d to the 15th. times 3 c to the 4th d to the 1. Okay, the stuff that has a perfect cube, which is this, and the stuff that does not, which is this. And now we take the perfect cube, and this thing just transfers down, right? Just because it doesn't have. All right, let's risk it. Let's go ahead of page. Oh my God. Oh, expressed as an entire radical. This is different then, right? So now we want to move things underneath a radical sign. Okay, so this is square root, right? So we need to write 5 as a square root. So what's 5 the square root of?
Root 25.
Yeah, so it's the root 5 squared root 2, which is root 25. It's all just going to disappear anyway. So as an entire radical, it's root 50. Negative 4 root 3, we cannot put the negative, right? So this thing, negative 4 root 3, if you evaluate it, it's a negative number, right? So we can't square the negative 4 and then with a positive 16 and say, hey, negative 4 root 3 is the same as positive root 48. No, that can't be because one's negative, one's positive, right? So with a square root, okay, here we go. Okay, now we can go. All right, so it's the negative, then the square root, right? So 4 is the square root of 16. So that's negative 16 times 3, which is negative root 48. Okay, so we got to square the 3x, gives me what? 9x squared, right? Times 2x, which is the square root, let's just cut to the chase, 18x cubed. Okay, at some point we got to realize that we could do big kid math now. Have to write it all down. Okay, so this is the square root of 16x to the 6th times root 5, which is 80x to the 6th. This is negative. Negative stays out front. Square the 8a to the 4th, giving me 64a to the 8th times the root of 7a, negative 420 and 28 is 468. A to the what? 9. Okay. Keep going. All right, so now we got cube roots. Now we got to cube the 6. Right? So we write 6 as the cube root of whatever 6 cubed is, which is 216, times the cube root of 5, which is the cube root of 216 times 5, which is the cube root of 1080. He said questioningly, but yeah, it's 1080. Okay, if it's an odd root, then the negative can go under the radical sign, right? So we're allowed to do that. So this is the cube root. So I cube negative 2, and I get negative 8 times the cube root of 4, and in one step that becomes the cube root of negative 32. Okay, so a negative sign in front of an odd power, we will end up with the negative sign under the radical, right? Because we want an entire radical, I don't want the negative of. But if it's a square root or an even root, then I need it. Yep.
64 times 7 is 448.
440 what?
448.
No, can't add. Thank you. And thank you for doing it now and not after I turn the thing off and then I got to go in and write a little text box saying yes, we can actually multiply something. Although apparently I can't. But okay, so this is the cube root. We got to cube the 3x. What's that going to give us? 27x cubed, right? Times the cube root of 5, and what's 5 times 5? It's 135, right? Anyways, check my arithmetic. That's just arithmetic. Variables. So m to the 4th is the cube root of what? M to the 12th, right? Just going to multiply by 3, reversing the process. Times the cube root of m squared, which is ultimately the cube root of 14, right? Multiply powers with the same base, so we're bringing them together under the radical sign. M to the 12th times m squared is m to the 14th. We can do it, I think, maybe. Negative 2y to the 5th. What do I get when I cube that? Negative 8y to the 15th. Times the cube root of 7y squared, which is the cube root. Negative 56y to the, and what do I need to fix up before we go to the next page? Needed 3 in the index, right? Easy to leave off. We shouldn't want to cost ourselves. Now, we're not going to take it off each time you do it. So if you leave off 6 indexes, congratulations, you just lost 6 marks or something. But well, if you leave it off 6 times, you might lose that. But express in ascending order. What's ascending mean? Going up. Yeah, smallest to largest, right? So smallest to largest. Don't worry, it's not going to write. And then we got 6 minutes. Okay, so if they're all cube roots, then all we need, or all square roots, or all fourth roots of that, we need to change them from mixed to entire, right? And then just look at the number underneath, right? And they'll be in order smallest to largest. Okay, so 7 cube root 3. Okay, so I got to cube the 7, that's 343, right? And then I have to multiply that by... Oh, wait a sec. No, hang on. They're all the same, right? So ascendant, what's the answer? 3 cube root 3, 7 cube root 3, and 8 cube root 3, right? Those guys are all the same, but yeah. What are you done? Now, 4 root 6, 4 root 7, 4 root 5. Okay, that should be kind of obvious. What's it going to be? 4 root 5 is smaller than 4 root 6, which is smaller than 4 root 7. Okay? 9 root 2, 5 root 6, 8 root 3. That's a little harder, right? So here, there were all 4s in front, so it's just like, what's bigger? Well, root 7 is bigger than root 6, root 5, and there they were all cube root 3, so the numbers. So what we have to do here is we want to switch from an entire radical to a mixed radical, so 9 root 2 is root 81, root 2, which is root of 162. 5 root 6 is the root of 25 times 6, which is root 150. And 8 root 3 is root 64 root 3, which is root 192. So if I'm going to put them in order from smallest to largest, it's going to be 5 root 6, followed by 9 root 2, followed by 8 root 3. Okay, so with that one, because they were all different, I didn't have the same number in front, didn't have the same number underneath the radical sign. Convert entire radical, or sorry, mixed radical to entire, and then compare. Here, kind of the same deal, right? So they're all cube roots. Okay, that's cool. Convert from mixed to entire. So 3 cube root 5 is the cube root of 27 times the cube root of 5, which is the cube root of 135. 2 cube root 15 is the cube root of, so I just got to cube the 2, right, which is 8. Cube root 15, and 8 times 15 is 120. And 4 cube root 2 is the cube root of 64 times the cube root of 2, which is the cube root of 128. So now we can put them in order, right? The smallest one, now we're just looking at the numbers underneath the radical sign. So the smallest one is 2 cube root 15, followed by 4 cube root 2, followed by 3 cube root 5. Is this it? Is this the last thing? Oh, we do that. We take our time now. We got, this watch is a piece of... Was there another page after this? No. Okay, what is there? 2 more? C and D? Is there a D? Huh?
We're on E.
We're on E? Oh, okay.
It's right there. What?
Yeah, okay. Oh, we did, whatever. Okay, 7 cube root 2, 6 fourth root 5, 4 square root 5. Use your calculator. Okay, seriously, there's not much else you can do, right? Like, they're not all cube roots, so, the last one, they were all cube roots. I write them as the cube root of this. Here, it's 7 times the cube root of 2, and 6 times the fourth root of 5.
How do you do a fourth root?
Ah.
There's a little arrow right there.
Yeah, so you could do a couple of things, right? Let's here. Let's get the calculator out.
Oh, I guess one. So power of 1 over 4.
Yeah, you can do a couple of things, right? So all right. So we want to do 7 cube root 2. So 7 math cube root is number 4. So the cube root of what? 2. Enter. We get 8.82. So let's call that 8.82. And 6 times the fourth root, so you go 6. Now, you say, I'm doing a fourth root, so I got to put in the 4. Well, I can't put the 4 there, right? So you're going to actually have to say times 4, math. So in this case, number 5 is the x root. Okay, cube roots more like square roots are the most common. It's got its own key. Cube roots, less common, but still common. And then fourth root. So I got to put in the root, then number 5, so 6. And notice how it sticks the 4 in the index, right? I've got times the fourth root of 5, which is 8.97. And 4 root 5, which we could just do 4 second root 5, and get 8.94. Okay, so just throw commas in between them. They are in order.
They're not.
Oh, they're not in order? Wait, 8. Oh, right. Sorry. Don't just throw commas. Okay, so what do we got? 7 cube root 2 is the lowest. 4 root 5 is the next. And 6. Oh, breathe in. Okay, any mistakes before I hit done? Or is there anything that needs to correct? Anything else I need to correct? If it wasn't for the fire drill, we'd have been like, there were time. There were